All right, guys. So we're going to be covering, um, and I did put record on it. It's just I'm only sharing the browser, so you guys aren't seeing the recording thing. But I did record it. Just remind me to hit that save button at the end. So let's get into the tutorial. Um, I did have a good comment from someone who had tutoring in Algebra 2, and that's that they tried to do the tutorial at the same time I'm teaching the class. What I recommend, just take notes. Take notes and do the tutorial later. And yes, it does take a little bit of time, but if you're busy going from window to window, it is going to make you struggle in trying to complete the tutorial, and then you might get behind. It's better to just take notes, like listen to what I'm saying, look at what's on the screen, take notes. If you need me to slow down, let me know. That's why I've always asked, like, hey, does everyone get this? What I'm really asking is, has everyone copied this down? Um, so in this lesson, we're going to learn how to write parallel lines, perpendicular lines, vertical and horizontal lines. So for those of you guys that don't know, horizontal is straight across. If there's any skateboarders, just think when you're skating the vert. Vert is like the half pipe, so you're going up and down. Perpendicular, we're going to learn, is about 90 degrees. Parallel means these lines never touch each other. The way everyone reminds me of horizontal is like you're staring out into the horizon, like where the sun comes out. Never really made sense to me, but whatever helps you guys remember the difference between vertical and horizontal. All right, so first thing we're going to cover is the introduction and then parallel lines. So, learning about these lines, consider these lines. They want us to do the slope. So, they want us to consider the slope. So, slope is our m in the formula, y equals mx plus b. Slope is also known as our rise over run. It's our change in rate. How are we changing? By rising and running. Rising is how much we go up for every unit we run. This is also known as the change in y divided by the change in x. How much of the y changes every time we change the x? So let's take a look at this one. So our rise here, if we're starting off at 2 and we're going to go up all the way to 6, we rose 4. And then we ran 2. So then our rise over run, our slope is 4 divided by 2. Or in other words, 2. So our slope for AB is 2. I'm going to scroll down here. I'm going to put in a little 2. Next, I'm going to do this one. So this one, I'm starting off at -4. I go up 4, and then I'm going to go up another 8. So in total, I went up 12. So the reason why I like doing this visually instead of like the subtraction method is you have to do 8 minus -4 and then somehow figure out that that's 12. If you do it this way, you're like, I went up 4, I went up 8, that's 12. Or you can literally just count, whichever way works best for you. And then the next thing we have to do is we have to run. So we're starting off here at 1. And then I'm going all the way here to 7. So it's 6. So if I look at this, this is the same thing. This has the same slope, 2. And if you guys are wondering why that works that way, think of it this way. If I were to go up 2 over 1, I'm still on the line. And then I go up 2 over 1 again, I'm still on the line. Same thing here. Up 2 over 1, up 2 over 1. This is why reducing a fraction works. You can still be on the same line. So we got the same slope. And they do their rise second. I like doing my rise first. This making sense. Mr. Richard, do you by any chance know when we will go back to school? I don't, Jasmine. I know you guys are like seeing me back here. As of right now, we're slowly making the teachers come back, and then as we find it safer, the teachers will. I'm only back 1 day, so I know you guys are excited to see me in person. Not really. um, but hopefully, yeah, we'll get you guys going. All right, so let's talk about this. So when we're doing the introduction here, um, we're going to be talking about each step is parallel lines, right? So every step is parallel to the other. The going up part, so the post is perpendicular to the ground. So this handrail is perpendicular to the ground. Every rail you can think of as parallel as well. So we're going to be learning about parallel and perpendicular lines. I think a lot of people like online better. Um, I like I like both, to be honest, teaching online versus they both have their benefits. I get a lot more one-on-one appointments, but at the same time, I can't teach you guys like as a group during study hall here in the Nook. All right, so let's see this. So these two lines have the same slope. So this is one thing that we're going to learn about is that parallel lines have the same steepness. They're just as steep as each other. How do we call steepness in math terms? Steepness is slope. So that's all we're doing here. It's just steepness. So if we go over to the next one, we're going to figure out how to find steepness, whether we have a standard form or whether we have a slope intercept form. So when we're doing this, what's happening is here is simple. That's just our slope. For this one, in order to find our slope, what we have to do is we have to move over this A. So it becomes by is equal to negative ax plus c. And then we divide everything by b. So that's how come we get that negative a over b. And of course, they're going to show me right now. Oh, no. So here, that's just all we're looking at. We're just looking at this. This one, they're showing you the slope. This is an interesting way to look at it. Negative 2 over 5. This becomes negative when we move it over. And then we're going to divide it by 5. So it is an interesting way to look at it. I wouldn't memorize this formula. I would just remember to solve for y. If you solve for y, you'll find your slope. Memorizing another formula to me seems kind of pointless when it's like the slope's right next to the x. So if you solve for y, you just look at the number next to the x. All right. So then the y-intercept is our beginning point. So if we're solving for this, so here it's like just plug in your slope and do this. So, but suppose you wanted something. So let's say they're like, hey, you want a line parallel to this line. So they're saying, let's say you want a line parallel to this. Well, what you're going to have to do is you're going to have the y equals mx plus b. and you have to plug in this point and the slope. You don't know what the b is because you don't know where you're starting off. They're like, hey, your slope is 3. Here's this line. I want this point to be a part of it, but you don't know any other information. You just know the slope. So if you want to find the equation for this line, you're going to take this y, plug it into here. You're going to take this x, plug it into here. And finally, you're going to take the slope and plug it into there. So that's how you solve for a b. Does that make sense? You're just taking your points and plugging it in. Everyone good on this? Cool. All right, so moving on to this next one. So now it's like, now we'll write an equation, y-intercept form. So we have this equation. We want this point. So they're just continuing on what we did over here. So now that we know what b is, we just plug in our slope, plug in our intercept. That's all we need for a line. Lines aren't that bad, guys. Lines, all you need to know is the slope and you need to know the intercept. This one, they said it was parallel, so you already knew the slope. You just had to figure out the b. After that, that's how a line works. All right, so moving on. So the other one is point slope form. This is my least favorite form. The reason being is, yes, it gives you a slope here. So it gives you your slope. And it gives you a point. But it kind of... I thought you were just yelling at me, Vahi. You're like, yes, I understand it. Move on. For those of you joining us late, the question for the day is, what is your favorite midnight snack? I don't think I ever typed mine in. Let me type mine in right now. Cookies and milk. So the reason why I don't like this is you can solve this easily just using the y-intercept form. You can solve this using the y-intercept form by plugging in an x, plugging in a y. If you use this form, you kind of have to remember this is a general y, and this is the y. That's the general y. This is y of point. And that just becomes confusing. And this is your x of point. So I never like these where you have a general one. This doesn't make any sense. It's literally something you want to know later. All right. So what you're going to do here is if they give you a slope and a point, you plug in your 5, which is your y, into your y1, which is weird. And then your x goes into your x1. And then when you solve this all out, you'll end up, they didn't even solve it for you. You end up having to distribute, you get the 7x minus 14 minus 5, and then you add it up. So you add the 5 to both sides, and you get 7x plus 9. You'll end up getting the same thing. It's just a little weird. I personally prefer just using y-intercept form. I'm not the biggest fan of slope point form, but it is useful if you just plug it in and then just solve for y. Suppose you want to find the equation for a line that passes through this point and is parallel to this. So now guess what? Now they're only giving you 2 points. So in order to do that, you're going to have to figure out the slope. The way they do it is they're like the change in y over the change in x. Change in y over the change in x. How do we figure out the change? We're going to have to subtract. So if you want to find the change, you subtract. So you're going to take your y2, this one, and subtract it from your y1. Well, this is the same thing as just calling it your rise. By taking this minus this, you end up getting in this case, you end up getting a -3. You went down 3. So if you did 6 minus 3, so in this case, 3 is you always start at the right. Again, this is why I like kind of seeing it visually. Or if you're looking at it this way, -3, 6, 6, and 3. If you're looking at it as two different points, sorry, I meant to erase that. You're like, how far did I go? I went down 3. What did I do here? I ran 9. So that's how they're getting this -3/9. It's the change in y. It's this. So that's all this complicated looking formula is. This formula right here for a slope, it's our change in y. What changed? We went down 3. What changed with x? We went over 9. Is that making sense? Cool. All right. So that's how we end up getting this -3/9, which ends up being -1/3. All right. So let's take a look over here. So now they're giving us this, and they want us to do a line parallel, and it goes through this point. Well, in order to find a line parallel, we're going to have to find the slope. So we're going to have to figure out the rise over run. So if I look here, I'm going to climb up 1, 2, 3, because I'm starting off at 5 and I go all the way to 8. So I'm going to climb 3. And I'm going to run across. So I'm starting at -4 and I'm going all the way to +2. So going from -4 to +2, I'm going to end up going 6 places. If you wanted to do it by the formula, all you have to do for the formula is 8 minus 5 over, what's the y value here? 2 minus -4. So you end up getting this 3/6. All right. And then if we look at this, now it wants us to plug in this point. Well, the way I do this might be different from the way you do this. First of all, I want to reduce this to 1/2. Next, I know that my formula for a line is y equals mx plus b. So for my y, I'm going to plug in -2. For my m, that's my slope, I plug in 1/2. I'm going to plug in my x, which is 6. And then I'm going to, b is what I'm solving for. So is everyone following so far on where I got all of these numbers? Cool. Then I'm going to take half of 6. Well, half of 6 is 3. And then I'm going to take away the 3. So that way I get my b by itself. And I get this -5 equals b. So I know that my b is -5, and I know my slope is 1/2. So that's how they came up with this answer. Their b is -5, and their slope is 1/2. So if I were to graph it, what I would do is I would go down here to -5, and I go up 1 over 2, 1, 2, and then I would just make a straight line. And you can see that these lines look pretty parallel. Might be a little crooked because I don't know how to draw, but you get the idea. And right here, this is how they solve for slope, the same way I did it. And then they plugged it in. Actually, it's not really the same way I did it. I kind of did this begrudgingly because this is what they want you to do. But I just wrote my work here. So you guys can show your work like this, or you can say, my rise is 3, my run is 6, so my slope is 1/2. If you guys use your words, that's even better than showing me the math work, as long as you're explaining it correctly. So I rose 3, I ran 6. When I reduce it, my slope is 1/2. All right, let's move on to perpendicular lines. So parallel lines, just remember, parallel lines have equal slopes. Slope 1 is equal to slope 2. All right, let's move on. So what about perpendicular lines? So we're going to use a graphing tool. So this graphing tool, we want to find these lines to be perpendicular. All right, so right now the slope is 0. And if I go down here, that's not helping. Let me go over this way. So this looks like about 90 degrees almost. It would be right. Let me see if I can get this as close as possible. Right there is exactly 90 degrees. What I did here was basically this represents 1/2. So in order for me to find a perpendicular line, we're going to learn that all you do is you flip this over and you make it negative. That's how come I knew to stop here at -2. So that's all they wanted you to do with the graphing tool. Honestly, unless you knew what you were doing, you could get an approximation. Like you could be like, I think that's perpendicular. But unless you kind of knew the formula, there's no way you would know 100% certain it was perpendicular. So let's take a look here. So if we look at this, they're saying that the slope of a perpendicular line would be -2. So that's where we're going to learn about flipping this fraction over. So you can see here they have this 3 perpendicular. Well, 3 is the same thing as 3 over 1, so it's 1 over 3, and they make it negative. Well, this one's already negative. You can't make a double negative. Well, actually, you can. That's a positive. It is making sense to everybody. All we're doing is just flipping over the fraction, and if it's not a fraction, just put over 1. Cool. All right, so let's take a look at this one. Well, you guys already saw the answer, but let's kind of work through it. So the first thing we want to do is we want to find our slope. Now, you could remember that weird formula that was like -a over b, because this is ax plus by equals c. Or you can work it out like I said. Like I said, this is a weird way to kind of think of your slope. So what we're going to do here is we are going to just simplify this. So we're going to take away that 8x. So we get 3y equals -8x plus 10. And then we're going to divide by 3. So if we divide by 3, we get y equals -8 over 3x plus 10 over 3. So from here, we're going to end up flipping this over because we want a perpendicular line. So this becomes positive 3 over 8. Oops. I don't know why my computer decided to go on the next screen. I know you guys didn't see anything, but you can see that here. What are you guys talking about in the chat right now? You guys are all over the place. All right, so our slope here ends up being this 3/8. So just remember, you're always solving for y. By solving for y, it just means isolate y. Get y by itself. Isolate y. Get it by itself. All right, so our next one. So again, they're just showing us the steps on how to flip this over. So first we have to solve it. So if they give us a formula and they want us to be perpendicular, we're going to do the same thing. We're going to flip it over to get our slope and then plug in our point. That's all we're doing here. It's the same thing as a parallel line. There's just one extra step. Flipping over your slope. So if you want a perpendicular line, flip over your slope and change the sign. I was going to say make it negative, but change the sign is more accurate because if it's already negative, it becomes positive. If it's positive, it becomes negative. It's just not a matter of just like, oh, it's negative, I don't have to do anything. All right, so let's do perpendicular lines. So if we're going to do perpendicular lines, we need to find this slope first. So if I'm finding the slope first, what I'm going to do is I'm going to do my rise over run. So if I'm doing my rise over run, I'm going to see, wait, I'm not really rising. I'm more like I'm falling. So I'm going from this 14, I'm going all the way down to 2. So in other words, 14 take away 2, or I should, if you want to do it more accurately, 2 take away 14, because you always want to do from left to right. I'm going to go down 12. I went down 12. How far am I running? Well, if I look at my 4 and I go to 7, I ran 3. Or if you want to do it by the formula, again, I'm showing you just ways to do this. You guys pick whichever way works for you. You're going to do 7 minus 4. Always start from right, then to left when you're subtracting. So negative 12 divided by 3 is negative 4. So my slope is negative 4. All right, so I know that my slope is negative 4. And at the local park, you find a straight line of fountain, the path. The director's plan to make 2 paths. All right, so the first new path, you want to access the fountain and be perpendicular. So you still want to have this fountain right here. So that means you want to include this, what was this? 4 comma 14. You want to include 4 comma 14, but you want the slope to be perpendicular to negative 4. So if you want this to be perpendicular to negative 4, all you're going to do here is you want to flip that negative 4 over, and you get this 1/4. Now, does anyone remember how they got the 13? How am I going to figure out this 13 if I know my slope? Does anyone want to answer that? Remember, this is y equals mx plus b. I already know my m. How do I figure out my b? Anybody? Remember, I started off at negative 4. I know my new m is 1/4. Well, I already have my rise over run, Hector, so yeah, that's a good start. And I know I want to include this 4 and 1/4. So I already have my rise over run. But how do I find this b? Does anybody remember how I find the b? Where do I get this? I want to include the fountain, which is at 4, comma 14. What am I plugging in for y? Anybody? Come on, guys. I have a point here. What am I plugging in for y? Yep. Thank you, Hector. Yeah, I'm plugging in this 14, which following that logic, what am I plugging in for x? So I'm plugging in this 14 for y. What's my x? 4. Yep, exactly. Are you guys going to let Hector do all the work here? All right, so 1/4 of 4. So 4 divided by 4 is our 1. So from here, how do I get that 13? I get 14 equals 1 plus b. Okay. How am I going to get that 13? Anybody know? All right, guys. Come on, you guys have to be ready to answer questions. So I'm going to subtract the 1. That's how they got that 13. It's not rise over run so much, Hector. It's this idea of we're solving for b. So just remember, guys, if this is the key to everything. If you don't have your slope, which we already had, we had that 1/4. That was our rise over run. M is our rise over run. Our b is our y-intercept. The y-intercept, in other words, would be where we would start here. So they're saying that, hey, we have to start a line over here at 13, and then our slope is 1/4, and that's going to make the perpendicular line. So if we start at 1/4, we go up 1, go over 4, this line ends up being perpendicular to our original line. And here you can see how they figured out the slope. Again, I just did rise over run to figure out m. So first you figure out this. You're going to figure out that it's -4. But then after you realize that you have to do a perpendicular line, that's why they say opposite reciprocal. Opposite meaning change the sign. Reciprocal meaning flip it over. So if you guys don't know that, you might want to write that down. So opposite meaning change sign. Reciprocal just means flip it over. All right, so moving on, now we're going to be looking at this equation. So I know you guys see this equation here, but again, I want you guys to be able to solve it on your own, not just get these answers. So what we're doing here is we want to make a perpendicular line with the gazebo. The gazebo is our point G. So I know my slope has to be perpendicular to -4. So my new m, my new rise over run, is 1/4. That's my new rise over run, what I changed it into. That's the opposite reciprocal. Flip it over, or make it negative, and then flip it over. Change the sign, flip it over. So now, what's going to be my y for my new equation? I know my rise over 1 is 1/4. So what's my y for my new equation? Yep, 2. Exactly. And then that means that my x, by that knowledge, is y. So what's happening here is we get this really weird thing where we get 7/4, and we have to subtract it over to the other side. So that's why we get this really weird 1/4. The reason being is this is this. If you guys are still having trouble with fractions, let me know. I can explain this a little bit more. I want to make this 2 over 1 into something over 4. So I'm going to do that by multiplying the top by 4 and the bottom by 4. So I get 8 over 4 minus 1/4. And that's my b. That's how I solve for this b right here. Oops, this is supposed to be a 7. So that tells me that b equals 1/4. So that's how I'm getting this 1/4 right here. This 1/4, the one I'm circling in yellow right now, that 1/4 is our slope, our rise over run. That's what we flipped over right here. All right, so the next one is the two paths are parallel. Why are they parallel? Well, if we look at the slope, this slope is 1/4, and this slope is 1/4. So this kind of tells us that if we did this, we haven't done this yet. Sorry, I was thinking my geometry class. So because both of these lines are perpendicular, that means they're parallel. Their slopes are the same. They both have a slope of 1/4. That's supposed to be a 1/4. I know it's really hard to see. I'm sorry, guys. All right. So in other words, what we're going to do here is perpendicular lines have the opposite slope. So just remember that perpendicular lines have opposite upside down slopes. So opposite flip slopes, opposite reciprocals. Parallel lines have the same slope. So the two new paths that they made, these two new paths are parallel to each other because they have the same slope. So that's why it's saying because both of theirs is 1/4. So be sure to let me know right here that everything, what you guys were having trouble with, if you guys don't really understand the rise over run and things like that, let me know. All right. You guys should thank Hector for answering all the questions for you guys. All right, so moving on to slide 18, we're going to learn about horizontal lines and vertical lines. So again, here's the horizontal, here's the vertical. Think of this as the y is always going to stay the same. There's no change in y. Horizontal lines, a lot of people think of it as like, oh, it's like the x-axis, and that makes them think it's x equals something. It's not. There's no change in y. So just think of a horizontal line, no change in y. If there's no change, that means y is always the same. So if y is always the same, then it should be y equals. And if we think of a vertical line, the x never changes. See how the x is the same? That means it's going to be x equals a number. So let's kind of go over that. So if we're looking at this, look, this line has to be x equals -3 because the x is never changing. If we go to the next one, we see here that the y is never changing. The y right here is -7, and as we go across, the y is still -7. So the slope is 0. They mentioned that the slope is 0 here. There's no change in y. That's because if there's no change in y, it doesn't matter how far we run. We're running forever. We're running for infinity. This line is never going to change. If we're doing this way, we're technically never running, so it's undefined. We can't define this because we cannot divide by 0. And think of it this way. Remember how we said if it passes the vertical line test? Well, a vertical line fails the vertical line test because it is a vertical line. So it's undefined. It's not a function. You can't define it because you can't divide by 0. So if we're doing this, we're looking for the vertical line. So vertical, the x never changes. So if the x never changes, it's x equals, what's our x in this equation for x equals? X equals what? What's our vertical line going to be? X equals, x equals -1. What about this one? This one's a horizontal line. Is this x equals or y equals? For a horizontal line, what stays the same in a horizontal line? The y, yeah. What is that y value going to be? It's going to be y equals something. What is it? Yep, y equals 2. We're not changing our 2. Exactly. Good job, guys. All right, so let's move on. Let's do the unanswered. This one, it says a line perpendicular to the x-axis that passes through this point. So, in other words, this line has to be parallel. So this is x equals -4. It passes through this point. So if we have this x equals -4, and we're doing this other line that's going this way because it's perpendicular. In other words, we went from having a horizontal line, because this had to be parallel to the x-axis, this one right here. So what's the equation for our line now? Is this green line going to be x equals or y equals? Y, yeah. So we know it's not a. So what's our y for this point? Y equals what? Yep, y equals 7, exactly. Good job, Jasmine. All right, so if we move on here, let's take a look. So now's our summary. So hopefully you guys understand these a little bit better. Parallel lines, same slope, equal slope. This is always a good slide to take notes on, whether it's a video or one of these. Always take notes on this before you take your mastery test. Perpendicular lines. Perpendicular lines just mean that you're going to flip over your slope. Flip over and make it negative. Horizontal lines are always y equals something. Vertical lines are x equals something. So always take notes on this, guys, when you're finishing that up. And then another strategy I always recommend, take advantage of the practice. Take this practice like as many times as you want, and keep your score. So let's say, even though you don't get graded for it, like this, there won't be a grade on it. Kind of keep your own score, and until you get like that 80%, then you're ready to take your mastery test. That's the best advice I can give you.